everyone. We are going to continue working with our sine and cosine functions. In a previous worksheet, we looked at the sine function and we looked at having a radius of 10 units when we were looking at the bicycle tire. And so what that did was it stretched our function, and so we called that the amplitude. We also had the midline, so remember we moved that horizontal line or that ruler, and that changed where our midline existed. So the ruler was in the middle of the tire, it was on the table, and it was also on the floor. So that gives us our midline. And then the period was looking at how long it takes to complete one full cycle, and it took 3 minutes to complete one full cycle. So that's how we saw it in a previous worksheet. So we're going to build off of that today. So you can see here that I have this generic sine function, a times sine of bt plus k. The a value is going to represent the amplitude. So if we think about the radius of our tire, if it was 10 inches, that stretched our function. If we did a bigger tire of 20 inches, that would also stretch our function vertically. If we did a smaller radius of radius 1, that would compress our function vertically. So let's make a note of that. So the a is the amplitude, and that is the vertical stretch and compression. So when a is greater than 1, we have a stretch. When a is between 0 and 1, we have a compression. Let's talk about the midline. So the midline is represented by the k, and so that was when we changed our ruler. So the general relationship here is that k represents the vertical shift. And so the k value, if it's positive, or we could say k is greater than 0, meaning it has some positive value, that means the function is going to shift up. If k is negative, or k is less than 0, it's going to shift down. Okay, so notice that the a and the k, we refer to them as outside the function, which is why it is doing something vertically, because it's affecting the output. So it's affecting the vertical value. So it's either a vertical stretch and compression or a vertical shift. Okay, now let's talk about the b value. So the b value gives us the horizontal stretch and compression. So if we took our wheel and moved it faster or slower, that would change how long it takes to complete one full revolution. Okay, so the b value is our horizontal stretch and compression. And the reason why it's affecting things horizontally is because notice that it's b multiplied by the input. So we're affecting the input values, and the input is on the x-axis. So the inputs are being affected horizontally. And then the horizontal stretch and compression is actually very counterintuitive. So if b is greater than 1, it's going to be a compression. And then if b is between 0 and 1, it is going to be a stretch. Right? And if you compare it to the vertical stretch and compression, you can see that that's backwards. And that's because when we think about the b value, you want to think about it as speed. So if the speed is greater, it's going to take less time to complete one full revolution, right? And so that's why we end up with a compression. So if our speed is greater than 1, it's going to take less time to complete one full revolution, which compresses our function. Okay, and then if our speed is slower than 1, then it's going to take more time. Right, so if you think about driving to Denver, if you have a slower speed, it's going to take you longer to get to your destination. And so when we bring it back to our information here, if b is between 0 and 1, that means you're going slower, so it takes more time to complete a revolution, which gives us that stretch. Okay, and there is a relationship between how long it takes to complete one full revolution and the b value. So one full revolution is going to be 2 pi on our circle. And when we think about how much the function is stretched or compressed, it's technically the reciprocal of the b value. So technically it's 1 over b, but because one full cycle takes 2 pi, that gives us 2 pi over b. And we're going to do some examples to represent this. Okay, so let's get into problem 1. So these two graphs that are shown here are from the 7.1 worksheet looking at our tire. The first one we're going to look at is the one where the ruler or the horizontal line was right in the center of our tire. And we ended up with this graph right here. Notice that it peaks out at 10, and then the bottom of the valley here is at negative 10. And then we were oscillating, that middle is right around the 0 mark right here. So that means that 0 is going to be the midline. And remember from what we just talked about above, the midline is going to be represented by our k value. So let's make a note of this. So midline is going to be 0, which is our k value in our equation. Our amplitude is how much that function was stretched. And so from the midline to the peak is going to be 10 units. And then also from the midline to the bottom of this valley here is also going to be 10 units. And so that means that our amplitude is going to be 10, which is going to be our a value. All right, and then the last thing is the period. So we're going to do the period is equal to 2 pi over b. And we want to be very careful. The period and the b are two different values. A lot of times students will confuse the two, or they think that they're equivalent to each other, but they are not. There's just a relationship between the two. So the period is how long it takes to complete one full cycle, and the b is the value that goes in the equation. So what we're going to do is look at our graph, and remember the period is going from peak to peak, and in this case our period is going to be 3 minutes. So that means that the 3 is going to be plugged in for the period, and then we need to solve for our b value. So let's go ahead and do that. So we have 3 is equal to 2 pi over our b value. And since we're trying to write the equation, we need to find this b value. So what we can do is multiply both sides by b, which allows the b's on the right-hand side to cancel. So we get 3b is equal to 2 pi, and then to get b by itself, divide both sides by 3. So that means that our b is going to be 2 pi divided by 3. We can plug that into the equation, or if you prefer to plug it into the calculator and find its decimal value, you can do that as well, which we get 2.1. Okay, so now this is the b value that will get plugged into the equation. Notice that it's different than the period. The period was 3, the b value is 2.1. All right, so once we have all of these values, the midline, the amplitude, and the period, we can go ahead and plug them into our equation. Okay, so now we have the midline, the amplitude, and the b value. We can plug those into our function. So our function was a sine of bt plus k, so now we can plug those in. Our a is the amplitude, so that gives us 10 sine. Our b is 2.1 t, and then plus our midline, which is going to be our k. So technically we would write it as plus 0, but if we wanted to leave that off, that would be fine. Those two things are equivalent. All right, so that is our solution, or the equation for that function. Okay. Okay, now what I want you to do is take a look at this second graph, and I want you to identify what has changed from the first graph to the second graph. Is it the amplitude? Is it the vertical shift? Is it the period? And then once you discover what's different, then think about what the equation is going to be. So go ahead and pause the video to do that. Okay, so the only thing that changed in the second video was our midline. So the entire function was shifted up 46 units. So that means our midline is 46. The amplitude did not change. We're still with a radius of 10. And then our period, we did not change that either. We were still a 3-minute rotation, which means that our b value is still going to be 2.1. So this is the only thing that changed in the equation. So then that means our function is going to look like this. Y equals 10 for the amplitude, sine 2.1 for the b value, t plus 46. And that gives us that second equation. All right, let's go ahead and move on to problem number 2. So take a second and look at this function, and I want you to start to think about identifying the amplitude, the period, and the midline. So go ahead and pause the video while you do that. So our amplitude is going to be between 36.8 and 37.4, which gives us a total of 0.6 difference. Our midline is really what our function is oscillating between, and so that's going to be that middle value, which is 36.8. And then our period, let's talk about this again. So remember, period is equal to 2 pi divided by b. So since we have the graph, that tells us we can identify our period. So that period is how long to go from one peak to the second. You can see it's labeled here. So we're going from 6, an input of 6, to an input of 30 for a total change of 24 units. And so remember, that means that the 24 is the period. So we're going to plug that in there. So 24 equals 2 pi divided by b. And then from here, we can solve for b. So I'm going to change colors, multiply both sides by b, which gives us 24b equals 2 pi. And then to solve for b, divide both sides by 24. Okay, and then you can either reduce this or turn it into a decimal value. I'm going to go ahead and turn it into a decimal of 0.2618. So now we have all of our values. We have the a for amplitude, the k for midline, and then our b value. All right, let's go ahead and write our equation. So we have our function h is equal to 0.6 for the amplitude, sine of 0.2618 t plus 36.8. Okay, one of the questions I get asked a lot is, how did we know that the function was going to be the sine function? And if we think back to both the sine and the cosine function, remember that the sine function starts at the midline, and typically our cosine function starts off of the midline. So that's our general rule of thinking about the function. Now, if we have horizontal shifts, that does change that. So then we really want to think about some other things, which we'll get into later. All right, so this right here gives us our function for this graph. Okay, and then let's go ahead and do one more. So here we've got a person's blood pressure. P is given for time t in seconds by this particular function, and we're going to graph this function as well as state the period and the amplitude. So this is the first time we are given the function and then trying to graph it from that. You will notice that this looks a little different than that template that we saw before. So what I want to do is notice here that's starting with 100. The reason why it's written like this is because sometimes if we just started the equation as p equals negative 20, that equal sign and the negative sign can sometimes be lost. But for the discussion here, I want to show that visual. And then we have cosine 8 pi over 3 t. And then that 100, since I didn't write it in the beginning, I'm going to tack it on at the end and write it as plus 100. So now it makes it a little bit easier to identify our values. So right here, the negative 20 is going to be our amplitude. The cosine tells us which function to draw. The 8 pi over 3, this is our b value. So remember, the b value will help us identify our period. And then the 100 is going to be our midline, or the k value. Okay, so now we've got all three of our values. We can go ahead and start drawing. Let's go ahead and make sure we label our axes. So we have time in seconds as our input, and then the output is going to be the millimeters of mercury. And so before we start drawing, there's a couple things I want to mention. So when we think about our time in seconds, right, we want to think about those key moments in time where we have our starting position at 3 o'clock. I'm going to write these in for now, but we will eventually erase them. So this right here is our 3 o'clock position. This right here is our 12 o'clock position, our 9 o'clock, our 6, and then back at our 3 o'clock position. So even though these are not the time values, I still want you to be thinking about our circle and then those time positions that are important. Okay, so what we're going to do is let's focus on our b value for just a minute. So remember, our relationship is period is equal to 2 pi divided by b. In the previous problems, we were given, or we were shown the period, which makes it easy to identify. But this time we are not shown the graph, we're trying to find the graph. But we have the equation, which means that the equation is giving us the b value. So that means that we end up with period is equal to 2 pi divided by the b, which is in our equation, 8 pi divided by 3. And so from here, we now want to solve for our period. And notice that here we are dividing by fractions, and I know all of you love fractions. The same thing of dividing by a fraction is the same as multiplying by its reciprocal. So what we're going to do is rewrite this as 2 pi and then multiply by that reciprocal of 3 over 8 pi. Okay, and so then from here we want to actually simplify this. So notice that we have a pi in the numerator and a pi in the denominator, so we can actually cancel that. So we are left with 6/8. And I'm actually going to leave that fraction as 6/8, and you'll see why in just a few minutes when we start to plug it into our table here. So that means that our period is 6/8. So that means that's how long it takes to complete one full revolution. Now let's go back to our graph, and you can see that when I wrote these time frames from our clock position, that 3 o'clock represents one full revolution. So what I'm going to do now is erase the 3, and I'm going to write in 6/8, because that's how long it takes to complete one full revolution. Also remember that our 9 o'clock position is going to be half of that circle. So what I'm going to do is erase this 9 o'clock position, and we're going to take half of 6/8, which is going to be 3/8. Okay, once we have the 3/8, then we want to think about half of that, which brings us to our 12 o'clock position. So remember, this 3/8 is the 9 o'clock. Half of that distance is bringing us to that 12 o'clock position. So right here, we want half of 3/8. Well, that's not quite as easy to take the fraction of, so what I'm going to have you guys think about is 3/8, an equivalent fraction to that would be 6/16. So double the numerator, double the denominator. So now we want to take half of this 6/16, which gives us 3/16. And so now what I'm going to do is erase that 12, and then that position is going to be 3/16. Okay, so now let's go back to where we wrote 6/8. Let's think about what that equivalent fraction would be. Since the other values are in 16ths, let's write this one in 16ths. So this would be 12/16. And then hopefully you can see that there's a pattern there. So we have 3/16, 6/16, and then if we skip one, we get to 12/16, which means that this position should be 9/16. Okay, so then now I'm going to go ahead and erase this 6 and write in the 9/16. Okay, so these now give us the input times. Okay, for our graph, it doesn't matter which set of numbers. If you want to write in this set of numbers, do so they have the same fraction or same denominator, or you can write this set of numbers. They're equivalent to each other, but that gives us the breakdown of time for the first key moments of our graph. All right, now let's go ahead and get into the other parts of the graph that we want to draw. So we know that our midline is going to be at 100. So what I'm going to do is draw in a dashed line to represent that 100. So that's going to represent the midline. We know that our amplitude is going to be 20, which means that it's going to be 20 units above and 20 units below. So we're going to be at 120. And then below, or subtracting 20, brings us to 80. So that means that our function is going to oscillate right around that 100, going as high as 120 and as low as 80. So that takes care of our amplitude, takes care of our midline, and now we have our period. We know where our function is going to stop. What I like to do when drawing these graphs is I like to draw what I call a ghost graph. So that way we can start from there and then adjust it from that moment. You'll see that I haven't talked about this negative sign yet, which I will in just a moment. Let's focus on the cosine part of this graph. So if you refer back to the 7.2 worksheet, the cosine starts at the top. So here's where I'm going to draw like the ghost graph. So we're going to start up here. The next moment would be right here. The next moment would be down here. The 9/16 would be back at the 100. And then at 6/8 we're back at the 120. And so then we would draw our cosine function in right here. But remember, we haven't talked about this negative sign. So what that does is it reflects it over our midline. And so that's another key thing about transformations, is that when we negate it, we want to think about reflecting it over that midline. So that means that, I'm going to change colors here. So that means that instead of being at 120, it's now going to be at 80. So we're reflecting it over that 100. The 3/16 time frame, this dot is going to stay the same because we're reflecting it over itself. At the 3/8 dot, that is going to be at the 120, so it's reflecting over the midline. The 9/16, it's going to stay at 100. And then the 6/8, it's going to reflect over the midline. So instead of being 20 units up, it's going to be 20 units below. So now these create our dots. Okay, so I'm going to go ahead and erase those little orange dots. And then let's graph our function. So we're going to go ahead and connect those dots. So we get our function that looks like this. And so this becomes the graph of that function p equals 100 minus 20 cosine of 8 pi over 3 times t. All right, that is it for this video. We'll see you again in the next one.